Telepathy, the communication between two people without any involvement of text, speech or movement. It's all in your mind. Like normal communication, telepathy can be one way. I could listen to you without you speaking directly to me. Mind reading, telepathy, is it really possible? Well, no. But could we read a mind that we've created? We can't read the thoughts of a person, but perhaps we could tell what an artificial intelligence is thinking.
We've created many such minds. AI can analyse huge datasets. It can beat us at games like Go, but what is really going through AlphaGo's head when it places a stone on that board?
Let's go back in time for a moment.
Around 1935, a German guy called Konrad Zuse was working on a project in his parents' living room. The thing that you see here is what we would classify today as the first programmable computer. It received precise instructions on perforated film tape.
That word, programmed, has never left the world of computers since.
Whether it was punching holes in paper cards or pressing switches on a board of keys, humans have always found ways to communicate with their computers in order to tell them exactly what to do. Painstakingly precise instructions on what to calculate, what to store in memory, what to think. But that is changing with the increasing popularity of neural networks. You see, not all programs can be defined and solved through a set of simple, crisp rules.
Just imagine having to write a comprehensive set of rules that would allow a computer to recognize handwritten digits, when this, and this are all examples of the digit 5.
The pixels making up these images are very differently placed, even though all images represent the same number. Therefore, an artificial intelligence is not programmed in the traditional sense of the word. Instead, we have to train it. This neural network recognizes handwritten digits. To train it, we've shown it 60,000 pictures of digits, and we let it make a guess each time. If the answer is correct, great, nothing changes. But if the answer is false, then the connections between these neurons have to be changed. Once trained, however, a neural network is essentially a mysterious black box. The neural network makes decisions based on connections in the network, which are in turn determined by the numerical weights assigned to the neurons.
But these are just numbers. They reveal nothing about the inner workings of the network to a human observer. We do know that it works, but we do not know how.
To catch a glimpse of the way it operates, we can ask our digit recognizing network to show us what it thinks a number looks like by reversing the normal process. Instead of showing the pre-trained network a picture and asking it to determine the number, we give it a number and we ask it to draw us a picture. These are the pictures that our neural network drew. What the network has shown us here is this ideal representation of our handwritten digits. Let's take the digit 5 as an example. As you can see, this image has black, white and grey parts. The black areas are those parts of the example that make the network more confident that the image is 5. The white areas make the network less confident when they are filled in. The grey parts, well, the network doesn't really care much whether those are filled in or not. However, these images still do not tell us all that much about the inner workings of the individual layers, their connections, and the way the network thinks. So at the end of the day, neural networks do remain a bit of a black box for us humans.
Before I leave, I would like to show you one last thing. This is Faceception.
It's an AI that can describe your personality by analysing your face using neural networks. Faceception already works well for many use cases. It's even been used to detect terrorists. It can tell whether you might have some criminal tendencies.
So, in the future you might want to be careful what you look like, because you never know exactly what an AI may be thinking about you.